What's happening, dogs? Mr. Allen here. We got ourselves a pretty crazy math problem right now. Given the graph of f of x and g of x, graph h of x if h of x is equal to the product of those two. What? Well, let's think here for a second. Let's just calm down. Everybody calm down. Calm down. Calm down, everybody. All right. So f of x is a quadratic, and g of x is a linear function, right? A quadratic times a linear, a degree of 2 and then a degree of 1, is going to give me a cubic function. So it's either going to look something like maybe like this, or it's going to look like that, okay? So this would be a positive cubic, that would be a negative cubic. Well, which one is it likely to be? This is a positive quadratic, but this g of x is sloping down and to the right, so that's a negative linear. So we're looking at something like this, okay? So we're putting some pieces together. It's going to look something like that. How the heck is it going to look like that? Well, how about this? If I want to get some new points, let's say I'm going to look at this one right here, okay? So this, my x-coordinate is -3, okay? So my x-coordinate is -3. Well, if I'm going to multiply these two graphs together, I'm multiplying their outputs, which would be up here at +3 for f of x and 0 for g of x. What's 3 times 0? It's going to be 0. So I'll have that as my ordered pair. Let's try that again with now -2. -2, comma. Well, the green graph, f of x, is 0 multiplied by my orange graph, g of x, is -1, but 0 times anything is still 0. Okay? How about this? Let's go to this next point here. That would be -1, right? And don't forget to plot that point. -1. Well, if I take -1, that's going to be -1 times -2 is going to be +2. So now I have -1, comma 2. So it's that guy right up there. That's cool. That's cool. All right. Next one. We'll go with 0. So if I plug in 0, well, the green graph is 0, so it doesn't even matter what the orange one is, right? It's going to be 0. So I get 0, 0. So that point's right there. And then let's try one more. So we would have this point right over here. All right. And it's going to be, let's see here. For 1, I'm going to have -4, and I'll have +3, right? -4 and +3. That's going to give me -12. Woo! That got real big real fast going down. So that's going to be somewhere way down here. -1, -12. All right, just so it fits in there, we see it. Now, we said it's going to look something like this guy right here, right? Now, it's got to pass through these 3 points, that guy right there. Can I fit something like that? Well, again, let's take a look here. I'm going to have, it's going to pass through. Let me just do a rough sketch off to the side here. It's going to look something like this. So I can fit this point maybe like right here, right? Comes down below, comes back up to this point right here. Then it comes up, maybe that's somewhere around here. Comes back down right there. And then I can hit that other point. Oh, look at that. I can hit it all. So let's do it. Let's do it. Woo! Nice. See, that wasn't so bad. And they went exactly how we thought. It was going to be a cubic function. It should be kind of loopy and fun like that, right? So that's the product of my f of x, my g of x, which now gives me this h of x function. Dude, we did it without equations. We were just going ham with some numbers, dogs. That's dope.